Hi guys, welcome back to my new tutorial video based on JetBot simulation using a ROS gazebo, and I have included the OpenCV also in this tutorial video. How to interface a non-ROS program using a ROS bridge library and interface with a ROS. And I give the step-by-step process of Notion documentation is in my description. Follow that. And the whole design of the robot is did by me in Fusion 360 and converted into the audio format, and I added plugins and I cloned it into the GitHub repository, and I give the GitHub link also in my description, and clone it into your directory, copy the repository from the link and clone it git clone and paste the link of that repository. After that, enter it and make akin make, and why this JetBot is an open source and it's around $250, and it's an AI based on reinforcement learning robot. You can learn some basics of AI, and these are basic things. What are the steps involved in AI training the data sets and how to do the program of AI bot. That all we understand using a JetBot. So in this tutorial, first step we involve in OpenCV. After that, we will enter into the object detection, object tracking, like that upcoming tutorial. And after that, navigate into the workspace and open the OpenCV command. And once you visualize what are the libraries and functions are included in that program, and I explain the program first. I include the ROS pay, and we are using a ROS. For ROS, we are using a Python 3 programming, and I include the ROS bridge. ROS bridge is a library which is used to interface a non-ROS programs into the ROS. So next, I include our CV, OpenCV library, and I subscribe the topic of our robot camera or camera image. That is an topic of publisher node, camera node, and it will be subscribed by the OpenCV, so it will be receive the image information from the camera node. So I include the function statement first. After that, I include the subscriber statement second, and finish the program. And what is the main thing? It's like on basic subscriber publisher working principle only, but we include some certain libraries, so it will work by like that one. And our camera plugin is an publisher, and OpenCV is a subscriber. So camera plugin will be receive the image informations from the camera plugin to the OpenCV node using a topic of image raw or camera raw image. So it will be receive the information from that topic to the OpenCV node, and this is a command program which is used to interface an OpenCV to ROS. And after that, we involve or enter into the object detection, object tracking, color detection, color tracking, and is an base of A. And after that, launch the gazebo first. Gazebo is a simulation software, right? After launching a gazebo, play it. And after playing, use a JetBot or using a Fusion 360 design. To go to terminal and open another terminal, and launch teleoperate node, right? ROS run teleoperate to stickyboard.py. So it will be launch the teleoperation node first, and using the teleoperation node, the robot will be teleoperate by the keyboard command lines Using a computer keyboard, you can move your robot in the simulation environment. It is working by the publisher subscriber node, like our ROS core is a master and robot is a subscriber, and teleoperate to keyboard.py node is a publisher. Using C command well topic, it will be communicated by a robot, and node will be communicated by the command velocity topic. After that, launch ROS. ROS is a visualization software for visualizing the sensors data from robot. And type ROS launch, JetBot description space display.launch. Okay, copy the second command from the Notion documentation and paste it once. Using ROS, we can visualize the camera image, right? But once we enter into the OpenCV, it's easy to do the framework of the output of the image. So please go through the program first. After that, understand what are the steps involved in our OpenCV and enter into the beginner level and intermediate level of OpenCV using GitHub, and some resources are available on GitHub also. You can take and do the reverse engineering process. And after this, we need to launch OpenCV, right? For this, we use an OpenCV.py is an extension, Python code, right? So that we need to run ROS run, and we did not open any ROS launch file. So we need to launch OpenCV by using a ROS run OpenCV space package name, and which file we open, that name also we need to give ROS run, that file name of the OpenCV, and after that extension of that file, and it's showing error, right? What's the problem means we did not give the permission for that file, so we need to give the permission, right? For that we need to use chmod space x, so it will be give the permission for your file. Before that, type sudo ROS run OpenCV.py. Right. We did not give the permission, so we need to give the permission for that file for executing the program. So go into that package and type sudo chmod space plus x and give the file name of that one, and after that please enter it. It will be show it in green color. Before that command is showing in white color, right? Wait and see. Give the password of your system, it will take some time. Yes, now give ls. It's showing in green color, right? That's a problem. We need to give the permission and executing that program using a chmod command. Now our program is running, OpenCV program. Yes, now the frame of the OpenCV is visualized in our system. And I will explain the code once again with a brief explanation how the topic is publishing the image information to the OpenCV. Go to terminal and type ROS topic list. Open our program of OpenCV first, that OpenCV.py, right? And go through the program, go to the topic, subscribe topic, right? In that subscribe topic, we have a raw image, right? And go to terminal and type ROS topic list. It will be show the what are the topics running on your system will be showcase. And you see that RBot camera image raw, right? That topics we give to the subscriber node to receive the information from the camera plugin, right? So using that topic, it will be like we have a camera node here and we have an OpenCV node here, and in between we have a topic of that camera plugin, and the topic will be communicate between both nodes. So it will be send the image information to the OpenCV node, and it will be process the image and send to the robot. This is a basic thing of OpenCV using a ROS. And after this, you need to enter into the object detection, object tracking in upcoming tutorial videos, and you can take some resources, source codes from the GitHub and do the reverse engineering process. And before that, please make sure you are understanding the process of a node. Okay, go to ROS Wiki and learn the documentation of basic node processing, and you will understand some. After that, enter into the AI-based robots or vision-based robots using ROS. Okay, thank you. Please subscribe.